is the Goddess of Science Physics, and I'm Mrs. Bolton, and today we're going to do some potential and kinetic energy exemplars. Yay! So, let's dig right in. Let's do some potential energy stuff. Potential energy is calculated, as you can see from the formula, by the mass times our old friend acceleration due to gravity, which we know is 9.81 meters per second squared, times the height. Or, if you prefer, you can do the weight of the object, which is really mass times the acceleration due to gravity, times the height. Okay, so let's dig in here. So calculate the potential energy. So we're looking for PE equals of a 68 kilogram mountain lion. Kilograms is a unit of mass, as you know, 68 kilograms. That has, what is the potential energy he has when he's sitting on a ledge that is 2.1 meters above the ground below. Now, let's look at our formula and see what we have. Well, we don't have the potential energy. That's what we're looking for. We have the mass. We have the height. Oh, we need the acceleration due to gravity. So let's write that in as well. 9.81 meters per second squared. Okay? So, let me give this a little zhuzh here to see if we can get it a little bit sharper. I apologize for not having done that right off the bat. There we go. So, PE equals mass times the acceleration due to gravity times the height. And so in the work area, so we have 68 as our mass times 9.81, which is our acceleration due to gravity, and our height is 2.1. When you multiply all of those together, you get a very strange number, 1,487. Now, what is the unit for energy? Well, it's the same as the unit for work because work is energy. So that would be joules. Okay, so that's the first one. Let's see if we can do this second one. Calculate the mass, so we're looking for the mass this time, of an echidna that has 79 joules of potential energy, so PE equals 79 joules. When he is sitting on a rock that is half a meter tall, so height equals 0.5 meters, and because we already know the acceleration due to gravity is 9.81 meters per second squared, we can put that in. So our formula, PE equals mass times the acceleration due to gravity times the height. It's a P, by the way. Didn't make my stem very long. So we'll plug into that formula, 79 equals the mass, which is what we're looking for, times 9.81 times the height, which is 0.5. So the best way to attack this is to multiply these two together. So you get 79 equals a mass times 4.905. Now we're going to divide both sides by 4.905. So that goes away, so we end up with just the mass. And the mass, as it turns out, is 16.106 kilograms. You say, Ms. Bolden, why are there three numbers after the decimal? Well, remember the rule that I have you round by. It needs to be three non-zero numbers to the left of the decimal. So we have, that's a non-zero number. This is a zero number, so that doesn't count. And then the next, you go to the next number, and that is a non-zero number. So we have two non-zero numbers there. Okay, next problem. Calculate the height of a flamingo. So we're looking for a height is sitting at, if the mass of the flamingo is 3.6 kilograms and it has potential energy of 62 joules. And we know that if we're doing potential energy, we're going to have to use the acceleration due to gravity, which is 9.81 meters per second squared. Formula is exactly the same. And let's plug into that formula. So we got the potential energy of 62 equals the mass, which is 3.6 times 9.81 times the height. Let's multiply these two numbers together. So you get 62 equals 35.32 times the height. Divide both sides by 35.32. And you get the height equal to 1.76 meters. Okay, so those are the potential energy problems. Let's try a kinetic energy problem. So calculate the kinetic energy, KE, so we're looking for KE, of Crash Bandicoot, who is moving at 2.1 meters per second. So velocity is 2.1 meters per second, and has a mass of 0.23 kilograms. So the formula, KE equals the mass times the velocity squared divided by 2. Now be aware that it's only the velocity that you're squaring. It's not the product of the mass and velocity. If it were the product of the mass and velocity, there'd be a parenthesis around both of them, and the square would be outside. So when I plug in to these things to make sure that I square only the velocity, I have a little trick. So what I do is I put the velocity 2.1 and square that, but put the whole thing inside a parenthesis so that I know I have to do that first because of the order of operations. And then we're going to divide it by 2. It's really important that you remember to divide by 2. If not, you're going to get it wrong. So when you do the math for that, it comes out to be 0.507 joules. So you'd square 2.1. If you don't have a calculator that has a square button on it, you could just do 2.1 times 2.1, same thing. Multiply it by 0.23 and get the product of that, and then divide it by 2. So that takes care of that one. Oh, yes, it's joules. All right, I'm going to flip the paper. Don't be scared. Okay, on this side of the paper, it says calculate the mass of a pumpkin. So we're looking for mass of the pumpkin that is rolling at 5.7 meters per second. And the kinetic energy equals 98 joules. Awesome. So same formula, KE equals mass times the velocity squared divided by 2. So KE is 98 equals mass, which is what we're looking for, times velocity squared, 5.7 squared, putting it in parentheses, and then divided by 2. So the first thing that I'm going to do is I'm going to put a 1 underneath here, multiply these two together, and those two together. So 98 times 2 is, must flip my answer paper over, is 196 equals, and then while I'm at it, and mass times 5.7 squared. So now the next thing that I would do is I would square the 5.7. And so I get 96 equals 32.49 times the mass. Divide both sides because 32.49 is 5.7 squared. Divide by 32.49 to get the mass by itself. And that's going to give us 6.033 kilograms. Okay, that one was a little more difficult than the first kinetic energy one that we did. The third kinetic energy one is probably the most difficult of all because you have to use the dreaded dun 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 square root. Ooh, bad. But don't worry, I'm with you. We can do this. Okay, calculate the velocity. So we're looking for a velocity of a wheelbarrow filled with heads of iceberg lettuce. It has 500 joules of kinetic energy. So KE equals 500 joules. And it has a mass of 70 kilograms. Okay, so write our formula. Equals mass times velocity squared divided by 2. So we get 500 equals 70 times v squared divided by 2. Easiest thing to do here is to multiply these two things together and set them equal to those two things. So we have 1,000, 500 times 2 is 1,000 equals 70 times velocity squared. Now, before we start attacking that velocity squared, let's get the v by itself on that side. So we're going to divide by both sides by 70. When we do that, you end up with 14.29 equals, and the 70s go away, v squared. Now, here's the tricky part. You're going to do a square root of this. So you're going to square root this side, and you're going to square root that side. And when you do that, you end up with 3.78 meters per second. Okay, so that's how you do potential energy and kinetic energy problems. You can use these exemplars when you're trying to do your homework. Hopefully you followed along and filled in as you went. They're a really great resource. So there you go. That's it for this time. Have a great day.